Hi, everyone. Let me say it's a pleasure to be here in the second year in a row. At the end, the organizers and all the organizations are very, very good, and I appreciate a lot all the stuff that they do. I'm Michel Murabito, but everyone call me Mitch. Please call me Mitch, because also my mother now call me Mitch. I'm a tech evangelist at Fractal Cloud. At the end, Fractal Cloud is a small company that provides solutions for platform engineering and so on. I'm a CNCF ambassador. I'm one of the organizers of Green Software Italia, where we talk about green software in IT, and one of the main organizers of Cloud Native Days Italy. About Cloud Native Days Italy, maybe. What? It's first. I don't know. Okay. We have just announced the next edition. It's in May in Bologna. Maybe some of you know Bologna. It's very, very good. And Monday we will open the call for speaker. We accept also first-time speaker. If you want to try to propose some stuff, I will to share the links in the Slack channel, the Cloud Native Bergen Slack channel. Okay. First of all, how many of you are a developer, like writing code and so on? Please raise your hand. And how many of you are ops, platform, and so on? Okay. Many platform, less dev. It's good. I want to start this story in around 2004. When I started to write code for my first job, the world was very, very simple. Just knowing PHP, HTML, a little bit of CSS, no frameworks, no stuff. And for deploy, you need just to drag and drop your local folder in the remote folder with FileZilla or like that. Who knows FileZilla? Okay, a lot of you. Nice. And was very simple. Now we have this situation. We have Cloud Native. Of course, Cloud is very, very great because we can do a lot of stuff with Cloud. We can create a lot of application with very large users that use it. And there is a lot of stuff that we can do with the Cloud. But at the end, the promise was be agile, we want to have velocity, and we want to scale. Sometimes also if it's not useful, because you know, I want to put my application in the day zero on Kubernetes with 20 nodes. It's not useful sometimes, but at the end, it's very important for large application. And we want to be resilient by design. In the previous talk, someone talked a lot of stuff about the resilience, when I will update and so on. And of course, all this stuff can help us for have continuous innovation. But there is a problem. Of course, it's not a really problem, but we need to understand that. This is the CNCF landscape. Who know the CNCF landscape? Please raise your hand. And who opened the CNCF landscape to find a new tool to use in your cloud platform? Okay, a couple. Maybe you know there is a lot of projects, a lot of repos, a lot of members, and a lot of contributors. But when you search, for example, a service proxy, you have around 23 different projects. Okay, not too much maybe, but if you need to search the right technology, you need to read all the projects, what they do, the feature, if you can use in your project, and so on. Or maybe you need a database. The talk about Gabriele, it's about the database, and there is 80 different projects related to the database. Maybe you know it's not all database. Maybe some can be operator for database. Maybe can be different stuff. But again, if you want to choose a right database to your cloud native application, you need to read 80 different projects. Of course, this is just the CNCF landscape, but outside the landscape, there is a lot of other projects. For some reason, maybe this project don't want to join in the CNCF landscape, but it's okay. And all these projects inside the CNCF landscape and outside create a lot of fragmentation, because one of you use Envoy, some of you use other service proxy, API gateway, and so on. This stuff means that today you have a lot of cognitive load. Who know what is a cognitive load? Please raise your hand. Okay, Alf, okay. The idea is you have a lot of effort to understand how you use stuff and how you use well all the stuff that the cloud native world provide to us. Of course, there is workflow friction, because sometimes you are slow to choose, make a proof to add a new tool in your platform or in your application, and sometimes that can produce a decision paralysis. Maybe half of the team want to use a service proxy, the half of the team want to use another one. We need to discuss, to understand, and using time for that. I put all the reference about the number in the slide. If you want the slide, I can share with you without problem. You can add me on LinkedIn and ask it, or on Blue Sky. I'm very happy to share all the material. But at the end, today, the developers need to manage 14 different tools. And the 97% of the developers saying that the content switch can kill the productivity. And all this stuff is converted to 6 to 15 hours per week used for tool friction. That means that maybe you lost 1 or 2 days per week just with this problem. Okay, but when we talk about cognitive load, we need to talk about the difference between intrinsic, German, and extraneous. Of course, there is some cognitive load that can be good for you. For example, the intrinsic load is the general complexity to solve a task. If a task is hard, because you need to configure a lot of stuff, or you need to create a new stuff from zero, maybe sometimes it's very hard to complete the task, but this task is depending by your skill, okay? At the end, you can improve your skill, and next time you can solve in an easier way. The second type, it's the German load. The German load, it's based by, let me say, it's the effort that you use to complete the task, but also learning stuff. Sometimes you have a new challenge, you have a good knowledge, but you can improve what do you do. And after that, after the task, you learn some stuff new that can be good for your career path, okay? Let me say, an example can be, if you need to choose a tool, sometimes maybe you know this database, but for some reason you say, okay, maybe I can search if there is another database that can be more good than the first one. And this research, it's part of the German load. The last one is the extraneous load, and it's depending not by you, not by your knowledge, and not by your volunteer to learn new stuff, but it's depending by the tool, by the workflow, and all by the stuff that your company can provide. For solve this last, there is a new discipline. Is not true, because I talk about platform engineering in the last 4 years, 5 years, but it's at the end a discipline to design and build paved roads, or golden path, someone call it golden path, to enable developer self-service, reducing cognitive loads. It's clear? You agree with this definition? Please raise your hand if it's true. Okay, not too much. I'm very curious about that. But maybe later we can talk about that. Okay, the adoption about platform engineering practice grow during the time. There is a research from Gartner, but also from Google Cloud that say in the 2026, the 80% of the big organization, we will use platform engineering practice. At the end, just to be at the same level, when we talk about platform engineering, we talk about try to centralize all the stuff in a single place, try to automate all the stuff using DevOps practices, try to simplify using new stuff. This can be and can increase the efficiency of your work and also the quality. But all this stuff need to be self-service. Just to do an example. Maybe you work in a company, your company have more than one business unit. You work in a business unit. When you need to change the business unit for business requirement or for any reason, you need to go in the new team and understand where is the cloud, where is the log, where is the dashboard, the documentation, how I can do the access to the, for example, repository and so on. Okay, of course, this is its effort that you use to understand how the new project works without make any result. Okay, at the end, the result of this process is start to work. But if you have a platform engineering tool, and this platform engineering tool have two different business units inside, you can work in the first one, and here in this tool you have all the logs, all the dashboard, all the information that you need. When you need to switch to the second one, the new manager can provide the access to the second one. And all the logs, all the dashboard are in the same place. Okay? That can be good. Another very useful example is about the environment. I'm Italian, also Gabriele is Italian. Today it's to talk from Italian people in the same stage. I'm very happy for that, because last year I'm alone. But at the end, when you need a new environment, because you need to do tests, sometimes you are autonomous and you can do that. But sometimes you need to ask. You need to ask to the ops team. And the ops team, the 90% of the case is not free for you. It's not waiting your request, but they have more stuff to do. And sometimes if your request is less urgent than others, you need to wait. But in the meantime, the business have a problem because there is a very urgent bug, but the other is more important, but also your customer is important. Let's imagine a place where you can click a button or run a CLI command and have your environment for your test. This is it when we talk about self-service and centralization. Okay, there is other research from other entity that say the key topic for make adoption of platform engineering can be increase the productivity, automate and standardize, improve security, compliance, and collaboration. But at the end, when you work in a platform, maybe some of your company have a platform team that are responsible to create the platform for the whole company, you need to look at the platform as a product. It not means that you need to pay a platform tool. Sometimes it's more useful than build by yourself, but it's not the idea. The idea is when you work in a platform team or when you collaborate with platform team, you need to look at the platform as a product. And of course, the customer are the developer. Sorry, when I talk about customer, it's not about front-end engineer, back-end engineer, it's also ops people and so on. Technical people. Okay, but maybe you already know all this discussion that I do until now. Please raise your hand. Okay, not all. Wow. But the platform engineering add complexity, add more cognitive load, if you think about that, because you have a platform to manage, the platform can be very complex. How you can create a platform that can be simple for your developer, but also for the people that need to manage the platform in the future. Because now, you know, the platform engineering world are very growing. All the companies start to build platform for any kind of stuff. And the idea to how solve this can be the composable architecture. Let me say, of course, the idea is try to don't scale the chaos, because if a developer maybe can be autonomous to create environment, and you have, I don't know, 1,000 developers, maybe 1,000 developers can create 1,000 new environment each day. If you think about that, it's crazy, okay? And of course, when you leave all the control about what the developer can do, maybe you can add new attack surfaces for someone that want to make strange stuff with your product, your platform, so. And during the time, the complexity of the platform can grow more and be a problem in the future. Okay, and of course, sometimes to try to stop this kind of problems, you add new process and new bottleneck. And that can be good because we start to use a discipline to remove bottleneck and reduce cognitive load. And after a couple of months or years, we add a new flow, new process that add complexity, cognitive load, and bottleneck. And we don't want that. We need to find a way to balance the power and the governance. Okay, the idea is this one. It's use a very simple principle called self-similarity. You know that principle, please raise your hand. Okay, no one. Oh, no, maybe one. I'm very happy for that. Because at the end, it's the idea it's gated by the nature. At the end, it's try to create complex and resilient system from simple and repeatable pattern. The idea is try to use same rules in different scale and try to, of course, predict the complexity. Just an example. If you add a new table in your database, you need to add a new CRUD for read, write, delete, and modify all the data in this table. Okay? But if you add 10 new tables, you can grow and scale this approach to the 10 table. For example, in the first case, you have just a class that can manage that. In the second case, you have 10 different classes that can manage that. You can put all together, and you know that the rule is for each table, you have just one read, just one update, just one delete, and so on. And of course, you can do that with anything. For example, one rule can be each services need to expand all the, I don't know, endpoint in the port 3000. Okay? Or all the logs are in the port, I don't know, one random port. What happens when you use a tool? It's easy because you have these two ports and you can do that. But sometimes you get this tool with other 10 different tools and put all together and create a new tools with more functionality and more stuff. But the rule is same valid. You can expose all the stuff in the 3000 and all the metrics in the other port, and so on. At the end, the idea is this one. If you look at a tree, for example, you have a single piece of tree that can be a perfect representation of the whole tree. Okay? And also for the snowflake, but also for Fibonacci sequence and so on. Okay, the idea is try to use recursion in your products to create this kind of systems and to compose new software, new elements compose different stuff in your system. And of course, this can enable the distributed governance, because if you have two different teams that work to two different tools, of course, each team is responsible for one of these tools. But when you put all together, the responsibility of the single tool remaining to the original team, not to the team that want to aggregate more than one stuff. But aggregating one of more stuff can create new idea. I do an example last year about that without, let me say, this theoretical stuff, and it's related to a payment system. Maybe you have an API, and this API can allow you to use a credit card to make a payment. Of course, it's a module. Okay, you can create this module, put in your platform, and each team that need to create a payment system can use this module to make it. A second team need to create a, let me say, invoicing system to do stuff. At the end, they have already the payment system and can get the module without changing nothing, or more or less. And after that, they can add a new module to generate a PDF document when a payment are made. Okay, it's another module. If you put all together, when a payment are made, a PDF are generated. Okay. The third team can get these two modules and add a dashboard. When a payment are made and the PDF are generated, you can put a metric somewhere and you have the dashboard. Of course, another team maybe can use just the API for the payment, or just the system to make PDF, or just the dashboard. Someone can use all together and maybe add new stuff. The all important stuff is try to be consistent when you try to find the right architecture to do that. And of course, all this stuff can generate for you predictable result, because if the model to make payment are the same in all the projects in your company, you know how it works. If there is a bug, you can solve one time and distribute the solution and so on. Okay, but this kind of concept can be applied also for infrastructure as code. You know infrastructure as code. I know many of you use Terraform or maybe use a lot of different tools. But at the end, when you create just a I want to make an example just with Terraform, but it's just an example. When you make your YAML for create your infrastructure, you need to choose which kind of element you want to create in your infrastructure, like a bucket, just a simple example. But when you create a bucket in Terraform, you need to choose before the cloud operator that you want to use. Okay? And if the cloud operators change, you need to change some stuff in your YAML. It's not scalable, because if a team use, I don't know, Google Cloud and another one use AWS, you need to change a little bit. And the 90% of the case, it's made by copy and paste. Okay? Someone are created the stuff to manage a bucket on GCP. You copy that, you change some parameters, and after that you have the version for AWS. It's easier, okay? But it's easier if we talk about a bucket. If we talk about a cluster Kubernetes with network policies, with a lot of different stuff inside, can be very complex. A dynamic path can be, for example, try to create a blueprint generic, and after that, when a developer needs to create the new environment, use the blueprint with a cloud provider, and some stuff are put together and generate the result in the cloud provider that you want. Of course, this is just an example. There is other example, like if you use system like Terraform, sometimes okay, it's very wonderful. I love Terraform, but it's just to make a couple of examples. With Terraform, if you need a new environment, you can create a pipeline to build the pipeline and process the YAML file and create the environment. But sometimes you need to change stuff. Like maybe you have an application, you have, I don't know, 1,000 different customers. Each customer have a different SLA or different contract about your service. If they open a bug on Jira, it's just an example, you can automatically run a pipeline to create a new environment, and the developer can use this new environment to make tests, to create the bugs fixing, and so on. But if you think about that, it's static. You can't choose depending on the customer or depending by other parameters. You can run the pipeline, yes or not. Of course, you can have 10 different pipelines for each case, but can be a very huge problem because you start to grow without any kind of government behind that. With another system, maybe you can have a programming language that get the information and say, okay, this customer have priority SLA. I need to solve that very fast. I can create the environment for the developer. Or in that case, maybe is no, the customer is don't have any SLA, don't have any contract about maintenance, don't create the environment because it's not useful for the case. Okay, at the end, the idea is one part is related by the architecture, try to have a central control plane to orchestrate all the blueprints that we talked before. And of course, each blueprint, it's compliance and service, and there is that contain an architectural part. The life system, the life cycle can be, for example, a developer need to discover or create new stuff. He can, of course, search in the blueprints list, find the right case that he need to use, and after that can get these blueprints and create from that a live system. Or sometimes you need to modify a live system that you already have. In this case, the developer can integrate stuff, can put new parameters, new piece of the blueprints, and add in the live system. Of course, this part can be done by an AI. Let's look about AI. I know maybe you want to listen a lot of stuff about AI, but I love it. It's very great that the website and all the stuff about the conference is generated by Copilot, and it's wonderful for some reason. But for other reason, I think that we start to talk too much about AI. Every company start to put AI in any case, and sometimes can be good innovation. Sometimes it's just try to surf the recent buzzword. Okay, just to be sure. Of course, the AI are critical or important for more companies. But when I talk about AI in this topic, I don't talk about create a platform to manage AI system, to create new models or so on. When I talk about AI, when I will talk about AI in this talk, I will talk about platform that can be use AI to make stuff. Okay, is not the goal is not create new tools, but it's use the tool to create new stuff. Of course, the AI can improve the developer experience. For example, yesterday or today, some of you use some stuff like when some error happens, I have the logs, I can have a trigger, and the trigger can change stuff like reboot a service, or maybe send an alert to Slack, to a mail, and so on, and the people need to control and check that. Of course, it's a simple task executor. The second way, it's today or tomorrow, can be try to analyze and predict the data before the problem happens, and after that, with the data and the AI model, try to predict the problems and act before the problem happens. Okay, just a couple of examples. Here we have developer or a tech person that can interact to the platform. Okay, inside the platform you have a lot of data. Okay, it's not related about the data of your database, but it's related by your system. You have the description about the nodes, the description about the network, the security policy, and also the logs, and all the stuff that you can use for create stuff. In another place, sometimes, always, but I'm not sure about that, you have logs, docs, and context that you can use with your AI. You can put all together in this black box, because at the end for us, or for the majority of us, the AI, it's a black box. Put all together to try to make stuff. The first one can be use a RAG. You know what is a RAG? Please raise your hand, because I need to count a little bit. Okay, not all of you, half of you. But at the end, the RAG, it's very simple. You have in some location data. This data is represented by string of text and a vector. Okay, if you don't know vector, it's like a coordinates, maps coordinates. When you do a question, you can convert this question to coordinates, and after that get the document that are near to the first coordinates. Okay. At the end, it's like latitude and longitude. You put a document in a point, you have a question. From this question, you create another point. You can search the document near the point, get it, and provide it to the AI. The very wonderful stuff is that you can use this kind of system, and maybe you already use this system also with systems like ChatGPT or Gemini or others. Because if you put a document very complex, I don't know, 100 page. And after that, you ask some stuff that are in the document, the AI was very great to respond to you. Have the right answer, because you provide all the answer and a question. The AI needs just to read what you write, and you can do that. And this kind of system, the RAG, work in the same way. You pass, for example, if you want to create to ask to the AI how I can create a new fractal, you have the documentation to all the procedure to create a fractal, and after that the user asks how I can create a fractal. He get this document from our map, put in same prompt that you use for the question, and after that you have the answer. And this can be good because it's if you have all the code error in your documentation and all the logs, you can say to your system, which error I have in my system. You find, at the end, the AI find the line with the error, can get the code. In the prompt, have all the list about the code and what happens with the code, and they can answer to you. The second way, it's a little bit, okay, the first, it's more related to, I want to ask stuff, I want to obtain information for some stuff. The second, it's the agents. Who know what is an agent? Please raise your hand. Okay, yeah, of course, it's the hot topic in this semester. But it's great because the idea about the agent is have some small piece of AI specialized to solve a problem. In this case, you can put, for example, you can get the output from the RAG to make action. The action can be restart a pod, restart a system, or maybe change a configuration. But when you use this kind of, you need to have a blueprints, because inside the blueprints, you can define rules, okay? Just an example, you have an agent that get information from RAG, and when the system say that they start to use all the resources available, ask to the agent to add a new node. Okay, it's a good solution from your point of view? Raise your hand if it's a good solution. Okay, for someone, yes. But what happens without rules? Maybe someone attacks your system, they start to create a lot of requests, you add a node, after that you add another node, after that you add another node, and you have 1,000 nodes in 20 minutes. Maybe it's not the stuff that you want to. But with blueprints, you can add rules. The rules can be, each system in this department can be from 2 to 10 nodes. Okay, maybe when you start the product, you can create the product with 2 nodes. You can add this system. When you have a spike about requests, you can add 3, 4, 5, 6, 7, 8, 9, 10. And after 10, they say, okay, this is my maximum. I can move more if a human don't change the parameters. Okay, I have just 3 minutes if I have the right time, but I want to talk also about metrics. Because when we use metrics, a lot of you know the DORA metrics, right? You know DORA metrics, please? Okay. It's old. It's not for today. It's a good metrics in 2014. Now it's not sufficient because, for example, we measure the development frequency and so on. But today we can write code with AI. Maybe yesterday to create a new system we use, I don't know, 1 month. Today, just half day. It's a good metrics measure the deployment frequency? Of course, no. Of course, we are more faster. Yes, with AI we can improve and accelerate our work, but the output, it's stable? We don't know. And for this reason, we need to use this kind of metrics, but we can add also the space metrics. How many of you know space metrics? Please raise your hand. Not too much, just 4 or 5. At the end, the space metrics are very great because it's not related about, or the majority, it's not related about the product by itself, but it's related by, for example, the developer happiness and job satisfaction, the quality and the value that a new functionality provide, and also the commit frequency and the pull request counts, but also the effectiveness of the team interaction and so on. At the end, the idea to measure all the new stuff, it's not to use just a set of metrics, but try to combine new metrics and different metrics to try to answer a couple of questions, like, is our, for example, our developer frequency, it's better, but compared to the developer satisfaction? Or is the ranking, and so on. Of course, there is a lot of different questions that you can do. I put here just a couple, just to have a couple of examples. Okay, key takeaway. At the end, platform engineering, it's like the mission and the why we need to create stuff. And the idea is try to solve and reduce cognitive loads. How we can do that? We can do that in a lot of different way, but use the right guardrail and a composable architecture can be good for the future and for you. And we can use the AI as an engine to make all the stuff that we create more intelligent. Okay, of course, the problem is try to reduce the cognitive load. The strategy is use platform engineering, but try to using blueprints to create guardrails, measure all the stuff using space and DORA, not only one, and try to create and make platforms that are governed by design. Of course, this is it's in the gray box. It's a suggestion because stop adopting AI tool, but start design intelligent platform to create more governed and autonomous evolution. Because I thought that in the last years we start to add AI in any stuff. Sometimes it's not useful, and please be responsible to that. Okay, feedback, Q&A, and photo. If you have, I don't know if I have time.
Fortunately, we are running out of time.
Okay, but I make a photo with you. I try to make, you are very too much. And thank you for the attention. If you have any question, we can talk in the break or during the day. I'm here all the day, and please stop me and we can talk about each topic that you want. Thank you.